आज का सेशन है मैट्रिक्सेस। यहाँ हम मैट्रिक्सेस के बारे में समझेंगे। मैट्रिक्स क्या है, उसके एडवांटेजेस क्या है, यूज के प्रॉपर्टीज, मैट्रिक्स के टाइप्स और मैट्रिक्स ऑपरेशन। व्हाई मैट्रिसेस? मैट्रिक्सेस की जरूरत क्यों है? It reduces complicated systems of equations to simple expressions. ये complicated equation को simple expression में बदलता है, यानी simplify करता है। Adaptable to systematic method of mathematical treatment and well suited to computers, ये form computerization के लिए suitable होता है। तो matrix क्या है? A matrix is a set or group of numbers arranged in a square or rectangular array enclosed by two brackets. दो ब्रैकेट्स के अंदर स्क्वायर या रेक्टेंगुलर के जैसे अरेंज्ड होता है, जैसे ये और ये। Properties: a specified number of rows and a specified number of columns. Two numbers, rows cross columns, describe the dimensions or size of the matrix. मतलब rows ये, column ये। Number of rows और number of column matrix के dimension या size बताते हैं। जैसे यहाँ 3x3 matrix, यहाँ 3 rows और 3 column है। 2x4 matrix, यहाँ 2 rows और 4 column है। 1x2 matrix, यहाँ 1 rows और 2 column है। Matrix को denote ऐसे करते हैं, a bold capital letter, और the matrix के अंदर के elements को lower case letter से denote करते हैं। जैसे matrix A with elements aij, I 1 से m तक और j 1 to n तक। There are many types of matrix, जिनके बारे में एक एक करके यहाँ देखेंगे। Column matrix. Here, the number of rows may be any integer, but the number of columns is always 1. यहाँ सिर्फ एक ही कॉलम होता है, रो चाहे कितने भी हो। जैसे यहाँ एक कॉलम है and 3 rows. Here, 1 column and 2 rows. Here 1 column and m rows. Row matrix. Any number of columns but only 1 row. यहाँ सिर्फ एक ही रो होता है, कॉलम चाहे कितने भी हो। जैसे यहाँ एक रो है and 3 column. Here 1 row and 2 column. Here 1 row and n column. Rectangular matrix. Contains more than one element. And number of rows is not equal to the number of columns, that is m is not equal to n. A rectangular matrix A, denoted by aij and is in an order of m by n. Example, here, we see 4 rows to column, hence 4 by 2 matrix, and here 2 rows 5 column, so 2 by 5 matrix. Square matrix. The number of rows is equal to the number of columns. A square matrix A, denoted by aij and is in an order of m by m, or we can just say order m. In regular square two diagonals are there, but in matrix, that is square matrix, we consider only one, the principal or main diagonal, which is composed of all elements aij for which ij. Example, here 2 row and 2 column is seen, that is 2 by 2 matrix. Here 3 row and 3 column, hence 3 by 3 matrix. Diagonal matrix. मतलब, a square matrix जिसके main diagonal के अलावा सभी elements 0 हो. That is, aij is 0 for all I not equals j, and aij not equals 0 for some or all I equals j. Example, in this 3 by 3 matrix all element is 0 but for the principal diagonal, and similarly यहाँ is 4 by 4 matrix में diagonal के अलावा बाकी सब elements 0 है. Unit or identity matrix 1. A diagonal matrix with ones on the main diagonal को unit या identity matrix कहते हैं, मतलब matrix aij is 0 for all I is not equal to j, and aij is 1 for some or all I equals j. जैसे यहाँ प्रिंसिपल डायगोनल के सभी एलिमेंट्स 1 है। नल या जीरो मैट्रिक्स 0। एक मैट्रिक्स में सभी एलिमेंट्स 0 हो तो उसको नल मैट्रिक्स कहते हैं। मतलब Aij is 0 for all I, j। जैसे ये triangular matrix, a square matrix whose elements above or below the main diagonal are all 0, मतलब मेन डायगोनल के ऊपर के या नीचे के सभी एलिमेंट्स 0 हो। जैसे यहाँ इन दोनों एग्जाम्पल्स में मेन डायगोनल के ऊपर के सभी एलिमेंट्स 0 है और इस एग्जाम्पल में नीचे के सभी एलिमेंट्स 0 है। एक स्क्वायर मैट्रिक्स में सब एलिमेंट्स मेन डायगोनल के नीचे 0 हो तो वो अपर ट्रायंगुलर मैट्रिक्स है। मतलब Aij is 0 for all I greater than j। जैसे यहाँ और इस 3x3 मैट्रिक्स में मैं डायगोनल के नीचे 0 है। Similarly in this example all element below the principal diagonal is 0। एक स्क्वायर मैट्रिक्स में सब एलिमेंट्स मेन डायगोनल के ऊपर 0 हो तो वो लोअर ट्रायंगुलर मैट्रिक्स है। मतलब Aij is 0 for all I less than j। जैसे इस यहाँ और इस 3x3 मैट्रिक्स में मैं डायगोनल के ऊपर 0 है। स्केलर मैट्रिक्स डायगोनल मैट्रिक्स जहाँ मेन डायगोनल के सभी एलिमेंट्स सेम हो तो वो स्केलर मैट्रिक्स है। Scalar matrix is defined as a single number or constant। मतलब Aij is 0 for all I is equal to j and Aij is equal to a for all I is equal to j। जैसे ये एग्जाम्पल यहाँ इस 3x3 मैट्रिक्स में डायगोनल मैट्रिक्स के सभी एलिमेंट्स सेम है। इस एग्जाम्पल में सभी एलिमेंट्स नंबर 1 है और यहाँ 6। अब हम मैट्रिक्स ऑपरेशन के बारे में पढ़ेंगे। यहाँ मैट्रिक्स ऑपरेशंस, एडिशन एंड सब्ट्रैक्शन ऑफ मैट्रिक्स, स्केलर मल्टीप्लिकेशन ऑफ मैट्रिसेस और मल्टीप्लिकेशन ऑफ मैट्रिसेस समझेंगे। बिफोर अंडरस्टैंडिंग मैट्रिक्स ऑपरेशंस, we shall understand about equality of matrices। Equality of matrices. Two matrices are said to be equal only when all corresponding elements are equal. Therefore, their size or dimensions are equal as well. Example matrix A is said to be equal to B, as all elements of matrix B is equal to all the corresponding elements of A. This is A, this is B. Now we see all corresponding elements are equal. Therefore, A is equal to B. Some properties of equality. If A is equal to B, then B is equal to A for all A and B. If A is equal to B, and B is equal to C, then A is equal to C for all A, B and C. If A is equal to B, then Aij is equal to Bij. Addition and subtraction of matrices. The sum or difference of two matrices, A and B of the same size yields a matrix C of the same size. Cij is equal to Aij plus Bij. Matrices of different sizes cannot be added or subtracted. Let's understand some properties. Commutative law, A plus B is equal to B plus A. Associative law, A plus B plus C is equal to A plus B plus C is equal to A plus B plus C. A plus 0 is equal to 0 plus A is equal to A. A plus minus A is equal to 0. Where minus A is a matrix composed of minus Aij as elements. Examples. Addition. These are 2x3 matrices. This 7 adds with this 1 to give 8. This 3 adds with 5 to give 8. This minus 1 adds with 6 to give 5. Similarly, by adding 2 and minus 4 we get minus 2. Minus 5 plus minus 2 gives minus 7 and 6 plus 3 gives 9. Similarly, subtracting elements of matrix B from matrix A we get matrix C. 6 minus 1 is equal to 5. 4 minus 2 is equal to 2 and so on. Now, let's see. Scalar multiplication of matrices. Matrices can be multiplied by a scalar that is a constant or single element. Let K be a scalar quantity, then K is equal to AK. Example: if K is equal to 4 and matrix A is this, then 4 multiplied by matrix A is equal to matrix A multiplied by 4 is equal to this, that is 4 times 3 is 12, 4 times 2 is 8, 4 times 2 is 8, 4 times 4 is 16, 4x minus 1 is minus 4, 4 times 1 is 4, 4x minus 3 is minus 12 and 4 times 1 is 4. Properties: Ka plus B is equal to Ka plus Kb. K plus G, A is equal to K plus Ga. K ab is equal to K, B is equal to A, K, B. Kga is equal to Kga. Multiplication of matrices. The product of two matrices is another matrix. दो matrices को multiple करने से एक अलग matrix मिलता है. Two matrices A and B must be conformable for multiplication to be possible. मतलब, the number of columns of A must be equal to number of rows of B. Example: A multiplied by B is equal to C. यहाँ A 1 by 3 matrix है, B 3 by 1 matrix है, और इन दोनों को multiply करने से matrix C मिलता है, जिसका order है 1 by 1. Note: B multiplied by A is equal to not possible. क्योंकि यहाँ B का order 2 times 1 है और A का 4 times 2. Hence, number of column of matrix B is not equal to number of rows of A. In this case, A multiplied by B is equal to not possible. क्योंकि यहाँ A का order 6 times 2 है और B का 6 times 3. Hence, number of column of matrix A is not equal to number of rows of B. In this case, A multiplied by B is equal to C is possible. क्योंकि यहाँ A का order 2 times 3 है और B का 3 times 2. Hence, number of column of matrix A is equal to number of rows of B and we get C of order 2 times 2. In this example, this is multiplied by this to give this, that is, this is multiplied by this plus this is multiplied by this plus this is multiplied by this is equal to this. This is multiplied by this plus this is multiplied by this plus this is multiplied by this is equal to this. This is multiplied by this plus this is multiplied by this plus this is multiplied by this is equal to this. This is multiplied by this plus this is multiplied by this plus this is multiplied by this is equal to this. That is matrix C of order 2 by 2. Successive multiplication of row I of A with column J of B is carried out here. That is row by column multiplication is carried out. Example: here, this 2 by 3 matrix is multiplied by this 3 by 2 matrix. That is, number of column of this matrix is equal to the number of rows of this matrix. Hence it is conformable. Hence, we multiply like this. 1 times 4 plus 2 times 6 plus 3 times 5 is equal to 31. 1 times 8 plus 2 times 2 plus 3 times 3 is equal to 21. 4 times 4 plus 2 times 6 plus 7 times 5 is equal to 63. 4 times 8 plus 2 times 2 plus 7 times 3 is equal to 57. Thus we get this matrix 31, 21, 63, 57. Note, when an unit matrix is multiplied by any matrix we get the same matrix. Example: here we multiply this matrix by a unit matrix and we get the same matrix. Let's understand some properties. Assuming that matrices A, B and C are conformable for the operations indicated, the following are true. AI is equal to IA is equal to A, that is, Any matrix multiplied by unit matrix gives same matrix. A, B, C is equal to A, B, C is equal to A, B, C. Associative law. A, B plus C is equal to A, B plus A, C. First distributive law. A plus B, C is equal to A, C plus B, C. Second distributive law. Caution. A, B not generally equal to B, A. B, A may not be conformable. If A, B is equal to 0, neither A nor B necessarily is equal to 0. If A, B is equal to A, C, B not necessarily is equal to C. Example. A, B not generally equal to B, A. B, A may not be conformable. Matrix A is this, matrix B is this. When we multiply A and B we get ABI equal to this. B multiplied by A gives BA is equal to this. Here we see AB is not equal to BA. If AB is equal to 0, neither A nor B necessarily is equal to 0. In this example this is A and this is B. When we multiply these two we get 0 matrix, but here neither A is 0 nor B is 0. Transpose of a matrix. Matlab reverse. जैसे if A is a matrix of order 2 by 3, it is denoted as this. Then its transpose is denoted by A to the power T, and is written as this. Aij is equal to Ri to the power T, for all I and j. To transpose. Interchange rows and columns. The dimensions of AT, A transpose, are the reverse of the dimensions of A. Example, this is matrix A with the order 2 by 3. Its transpose A to the power T will be of the order 3 by 2. As to transpose, rows and columns are interchanged. Properties of transposed matrices. A plus B, T is equal to AT plus BT. AB, T is equal to BTAT. KA, T is equal to KAT. AT, T is equal to A. Here, we see that transpose of A plus B is equal to transpose of AE plus transpose of B. This is A, this is B, then A plus B is 7 plus 1 is 8, 3 plus 5 is 8, minus 1 plus 6 is 5, second row 2 plus minus 4 is minus 2, minus 5 plus minus 5 plus minus 2 is minus 7, 6 plus 3 is 9. This is A plus B matrix, and transpose of A plus B is this, that is, here rows and column are interchanged. This row is written as column here, and this row is written as column here. We get this matrix which is transpose of A plus B. Now, transpose of A is this. This row is written as column here, and this row is written as column here. We get this matrix. Transpose of B is this. This row is written as column here, and this row is written as column here. We get this matrix. And transpose of A plus transpose B is this. 7 plus 1 is 8, 2 plus minus 4 is minus 2, 3 plus 5 is 8, minus 5 plus minus 2 is minus 7, minus 1 plus 6 is 5, 6 plus 3 is 9. We get this matrix which is equal to transpose of A plus B matrix. Here, transpose of AB is equal to transpose of B multiplied by transpose of A. Example, this is A, this is B, then AB is 1 times 1 plus 1 times 1 plus 0 x2 we get 2, 0 times 1 plus 2 times 1 plus 3 times 2 we get 8, and transpose of AB is this. This row is written as column here, and this row is written as column here. We get this matrix ABT. And transpose of B is this. This row is written as column here. This row is written as column here, and this row is written as column here. We get this matrix. Transpose of A is this. This row is written as column here, and this row is written as column here. We get this matrix. Multiplying BT and AT. 1 times 1 plus 1 times 1 plus 2x0 we get 2, and 1 times 0 plus 1 times 2 plus 2x3 we get 8. We get this matrix. BT, AT, which is equal to transpose of AB. Symmetric matrices. A square matrix is symmetric if it is equal to its transpose, that is, A should be equal to AT. Example, this is square matrix A. Its transpose is this. This row is written as column here and this row is written as column here. We get this matrix, which is same as A. Hence, if a square matrix is equal to its transpose, then it is said to be symmetric. Note: when the original matrix is square, transposition does not affect the elements of the main diagonal, मतलब स्क्वायर मैट्रिक्स में उसके ट्रांसपोज के प्रिंसिपल डायगोनल में कोई बदलाव नहीं होता। जैसे यहाँ मैट्रिक्स से और इसके ट्रांसपोज AT में मेन डायगोनल के एलिमेंट्स सेम है। The identity matrix I, a diagonal matrix D, and the scalar matrix K are equal to their transpose since the diagonal is unaffected.